Good morning. It's great to have you both here today. I just wanted to discuss, we're here today to discuss about the Global Smart Grid Impact Project and report and some issues that come from that. Now, this project that was done by VaasaETT together with Ventyx, ABB, had a lot of findings. Some of those findings include the fact that smart grid is finally coming of age, that we are finally seeing a return on investment from smart grid. Benefits for customers, benefits for utilities in terms of return on financial investment, benefits for the environment, and a range of other benefits that are coming around from smart grid that are all in the report. Now, two of those particular issues that I want to discuss today are the issues of oversight in terms of the intelligence of the smart grid and how we can bring things together, because it was found in the report and in the research that a holistic smart grid is more successful than a smart grid with less components. In other words, the number of elements that you have within smart grid, the more elements, the more synergies you get, the more benefits you get. Therefore, it's actually an advantage to have more components and integrate those. The consequence of that being that you need more oversight and more integration. So two things that I would like to discuss today with you are on the issue of IT-OT integration and on the issue of asset health management. In other words, from the IT-OT, how you integrate, and from the asset management, how you manage those things that you have within the grid. But first of all, what I'd like to ask you a question is, what was the reason why Ventyx became involved in this project in the first place? Why did they want to understand more about global smart grid impact in the first place?
So I think if we look at smart grid, as you mentioned before, just the breadth of the projects that have happened out there, we really hadn't seen a resource for going through all the projects globally and understanding really what are those components that are making these projects so successful and how they interact with each other. So a holistic view of the approach of utilities globally and how they look at the benefits of smart grid was why we were really interested in this type of research.
And what would you say are in your opinion, what would you say are some of the most interesting findings from the research, from the investigation?
I think it confirmed a number of things, which is that a lot of projects now are focusing on how to get the most out of sensing, monitoring, controlling, automation, things that we might expect by looking across projects. But it also confirms that integration is a recognized key attribute for how to get the most out of what organizations are doing. And then, as you mentioned earlier, the idea that carefully planned projects that are multifaceted and that are planned correctly from the outset are more likely to deliver on the benefits that the projects are after, because some of these dimensions can be mutually reinforcing. Then I think the last takeaway would be, it's clear that there have been a multitude, hundreds of projects around the world going on, and we can learn from those, and it doesn't make sense to reinvent the wheel.
Yes. Now, in terms of that, one of the key things that we found from this was the importance of OT-IT integration. And we hear a lot about that at the event here today. We hear a lot of it. Now the question is, what actually is IT-OT integration, if we were to define it?
So OT is operational technology. If we think about it in the context of utilities, it's what is being done to actually get at how to better operate the assets and manage the business of going through the day-to-day operations of the grid. Information technology is what we do to analyze that, how to make sense of the data that's coming back, and how to apply tools to better understand how you plan, operate, maintain, replace, and go through the entire life cycle of the utility assets. So IoT integration is where we bring those two worlds together. And so this is a lot about bringing down the silos that are naturally kind of predisposed to within the utilities, and bringing together those two worlds of operational technology and information technology.
Now, what are you really trying to get out of this? I mean, what do you get out of it when you actually bring those two together? What are the real benefits that you derive from that? What is the reason for doing it?
I mean, there are a few different reasons. First of all, you can get improved operational benefits. So these will depend, based upon what your goals are. But for example, you can achieve improvements in safety, so some of these key metrics around reliability. But you can also get additional organizational benefits. So if you're integrating better, for example, with your workforce, by being able to send information out to them in the field that enables them to be more effective, and then to feed that information back into the utility operations center, you'll get these organizational efficiencies that go along with the operational benefits.
And in terms of examples, I mean, there are different examples that are mentioned in the report, but are there some that you believe stand out in terms of good examples of where IT and OT have been put together in an efficient or successful way so far?
There are three general instances that we've recognized and that we work with customers around. One that we'll talk a little bit more about later is this asset health management. A second would be distribution system optimization. So the ability to optimize the way in which you're running your day-to-day management and planning of the distribution system. And the last is in outage lifecycle management. So how to deal with unplanned, planned outages, and in the extreme case, how to deal with storm situations.
Now we hear a lot about, in the report, or we hear a lot in these events as well, a lot of people talking about what you can achieve through massive investment in smart grid. But you also hear more and more now utilities talking about the importance of avoiding investment and the importance of not spending on things that are perfectly good in the network already, or trying to prioritize and trying to identify where to put the money. Can you say more about this idea of asset health in the utility context? And how you can, what is it, and how can you actually achieve good asset health, and what is the reason for doing it?
Maybe I'll start off with the reason? Or?
Yes.
Sure. So if we look at some of the reasons behind asset health management, what we have is a lot of pressure on the capacity of these assets on the network. So how do we actually make sure that we have enough capacity to meet demand and flow power on the grid? So if we think about asset health, a lot of the drivers to that are trying to maintain the existing assets that you have. Utilities are also pressured with typically a very flat operations and maintenance budget, so they have to deal with that. So they have aging assets that are many places around the world reaching the end of life. And so you're stressing these assets when they're well beyond their asset predicted lifespan. So on top of that, we have a lot of aging workforce who have the knowledge and the experience of how to maintain these assets, to be able to predict what you need to do in order to maintain them. So those elements are really driving the need to have these solutions that can help utilities better prioritize and optimize those assets across the entire life cycle.
Do you think there is, in a way, a lack of realization for how much that can achieve at present?
Yes, there is.
Yes.
I think that they're just now starting to understand what those possibilities are. And so as we look at some of the examples, we're working with our partner, American Electric Power, on the Asset Health Center. And those benefits are just now being achieved because of the reasons that we mentioned before around a lot of the knowledge being housed in one place and a lack of the coordination between the information technology and the operations technology. We're getting to a point also to where the economics are making sense. The sensors are getting cheaper, the communications, the processing of that information, and so those elements are really enabling the asset health management to really come to life.
Thinking more of the future, where do you think that these issues that we're looking at now are going to go in the future? How are they going to develop? Because we're still early days, right? Smart grid is still in its infancy. We're already seeing these examples of things that are developing, but where do you think we're going to go over, say, the next 3, 4, 5 years? in this space?
I think today, if you take a case like asset health management, we're working on the assets that are where you get the clearest, biggest benefit up front. So at the moment, that's in the transmission space.
Yeah.
Over time, it might well make sense to move some of that capability down into the distribution area as well. But I think in general, if you step back and look at the drivers that are forcing utilities to change the way in which they operate, so increases in renewables, aging grid assets, etc., then what you see is that utilities are needing to focus on grid automation, are thinking about how to engage customers in order to help balance out renewables. So things like demand response, and that can be both on the load side, also on the generation side. Bringing in battery energy storage is another resource to activate. So there are these sort of clear drivers, and I think as utilities put together their business cases, the technologies are there. They're future-proof. They're generally they're interoperable, and you know, we can work together to put the solutions in place.
If we think of IT and OT integration, and we think of asset health, but we think of all the elements within the report, it was stated that it's not just what you do, it's very much the way that you do it. It's not about necessarily being the biggest, it's actually making sure that whatever you do it properly. And that was very key in terms of those projects which had the best returns on investment. If we think of these issues that we're talking about now, are there any sort of keys to success that if you want to be really good at IT-OT integration, really good at asset health, for instance, are there things which you have to bear in mind, things that are critical or prerequisites or drivers of success in this space? Yeah.
I think there's a couple of components to that. One is keeping in mind your objectives, right? And whether that may be cost, reliability, the way in which we engage with consumers, the renewable element of it, sustainability. I think keeping in mind those objectives is really important as we look at the large amount of information that's coming out of these systems. If you look at data for just data itself, I think a lot of times we can get lost in just what's available, what's coming off their smart meters and these devices, and we forget about what we're really trying to do. And I think one of the things that's important is to keep those business objectives in mind and to use that as a way to bring together these two different groups. So many times even information and operation technology lives in different departments of the world. So if we bring those two together through having a clear objectives, what we're trying to achieve, I think it really places the focus on what can we do with this, right? And it allows the team to use that information and that common goal to achieve, such as capacity, reliability, efficiency, sustainability, and better customer engagement.
Now, in a sense, you mentioned a couple of times the importance of the customer involvement, getting the customer engaged, and when you think of the other objectives that you have, the environmental benefits. Do you, and of course we've seen that those, you mentioned that, and it's mentioned in the report, that those projects that have a long-term view, a long-term plan and strategy for how they're going to gain all of these benefits perform better than those projects that don't, and also those projects that don't have a very clear financial objective don't achieve financial benefit. Now, thinking of that, would you say that, is there an issue here to do with how we balance those things out? In other words, in order to gain the investment potential, in order to gain the support of the politicians, of those that are responsible, the regulators, the general public, that we need to give benefits to all those other things and move gradually rather than just a big bang. Do you believe that a big bang is better than gradually rolling this out and proving the benefits as we go along, and being careful with how we're spending and managing those assets and integration? Or so do you think we sort of a big bang, as some people suggest, or just gradual implementation and getting it right?
I think what is useful is for utilities to plan quite a long way ahead. They're used to doing that anyway, and have a fairly holistic view as to what it is that they want to accomplish with smart grids. It's not necessary to start and do everything at once, but provided so it's then possible to start relatively small if that's the way that they want to, or to really accelerate and try and do something bigger. But the key is if you have the plan from the outset, then you're not going to make decisions that you might later have made a different way, because you're thinking ahead about what it is that you want to achieve next. I mean, a good example of that is communications infrastructure. If you know that later on you might want to run multiple applications over the same infrastructure, you might make different decisions about what it is that you implement at the outset.
Yes. Now, one thing that we also saw in here was that there's some argument that there's too much piloting, too much redoing of exactly what's been done 1,000 times before in other programs and pilots around the world, and that utilities are to some extent testing things that have already been tested a lot of times. Do you think that we have the potential already to move much quicker with smart grid than we are at present? Do you think that it's being held back by a desire or a fear of risk sometimes by utilities and the industry? Do you think we can sort of skip some of this trialing that we do, as is mentioned in the report, or do you think we do need to do a lot of testing?
I think it's a mix. I think some things you still do have to test. Some networks are different than others. Some configuration of things, the types of assets that they have are different than others. And I think, for the general principles, sometimes we do a lot of the redoing of the general principles. I would agree with that. Sometimes though we do have to test things on given areas of a network. For example, maybe they're trying to optimize the voltage and the wire of the network, and sometimes they may have just a different situation that no one has tested before. And so I do think it is good to iterate upon these things and continually try to get better by doing innovative projects. I think there is sort of an incentive sometimes to be risk adverse in getting out these projects. So the bigger the projects get, the more people worry about having these large risks associated with it. So I do think though that pilots can oftentimes give you that ability to work within a broader landscape of this technology that's proven around the world, and then to take it to the next level through continuously improving upon what you've done through these projects that may not have the risks of having this great breadth, but to get at something that's really innovative.
And that sort of feeds into another thing that's said in the report, which was that those projects which were more innovative tended to be more successful across all the pillars of return on investment. So in other words, what you're saying is that they shouldn't see innovation as a risk. They should see it as an opportunity. Do you feel now Ventyx is operating in different industries? Do you feel that the utilities industry can be maybe a little bit less risk averse than it is at the moment?
I see a lot of innovation. If we look at globally, there's lots of innovation. You take an example of one of our partners, E.ON, in Sweden, what we're doing there. There's such a move towards bringing together the operations technology, the information technology, engaging with the consumers in a way that is way beyond what we've done before. So I do think that there is a lot of innovation, and there is, yes, some risk aversion within the utilities, but what I find is there's always some group that is sort of leading the change. And I think just the breadth of the report of this research is a testament to that, about how there are so many utilities around the world who are seeing this as a thing that they must do, that their business model as it currently stands will not survive without innovating, without dealing with these new challenges that are coming on the grid, such as renewables and increasing demand in some areas and these aging assets.
That's very positive note. And I think if you look at 200 projects that were studied and billions of investments and a lot of innovative findings, that have been happening. So it actually seems that there is an awful lot of innovation going on, and maybe that's not appreciated by some in the industry. Do you feel that, looking into the future, would you say that there are any key barriers that need to be overcome, or maybe milestones that need to be achieved to go even quicker than we're going now? Are there things that we need to work on particularly hard, whether they be regulatory or whether they be structural or any other, or innovation related? Can you think of anything that you would like to see change in the industry to help the industry move even quicker and to help these return on investments achieve even more going forwards? Thinking of the future.
I mean, certainly regulations play a big role, and we all know that there are big differences in regulation by geography. Changing the regulations can enable utilities to create their business cases much more compellingly, to get faster approval from regulators. So this I think is one of the major topics that I think the industry is engaging with, and hopefully over time we'll continue to see improvements there.
Where do you see yourselves in 3 years' time? How do you see this industry in 3 years' time? How will it be different? What will this smart grid sector look like in 3 years? Will it be very, very different from how it is now?
Yeah, I do see it as being very different. I think that the whole connectivity of these elements of utilities are going to be much more blurred. As you talked about some of the business models that are changing, I think as customers get more dependent upon electricity, for example, we look at ways in which we can better engage. And what I mean by that is some people are even saying, well, why don't I just produce all of my own electricity as a consumer? Do I really need the utility network? And I think that it's putting a lot of really good pressure on the interconnectedness of these things to say, well, there are services that utilities provide. They can be connected together. You can have a distributed production even on an individual consumer level and still be connected with the grid. But I think some of the elements that will really change is how we view the lines in between these different areas, from generation to transmission to distribution to end-use consumption. And I think that the way in which we're thinking about that, going from a centralized to decentralized to even a mix of things, is going to change a lot. And I think that the ability to use technology to have that connectivity to make our lives more productive is going to be a key change that we see in the world.
I think what the report shows is in a sense that there is a lot of optimism. There's a lot of success that's already achieved in the smart grid, and there's a lot of best practice from around the world that we can learn from. That is already, if we can integrate all of those benefits, we can actually achieve far more success than I think was ever thought, even just 2 or 3 years ago. I'd like to thank both of you for giving your insight and opinions, and wish you all the best of luck with the smart grid going forwards. Thank you very much.
Thank you.